Hello, 6th graders. Welcome to Big Ideas Math, Section 9.5, Mean Absolute Deviation Lesson. Pause while you write Section 9.5 lesson in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is use the mean absolute deviation of a data set to describe the spread of a set of data. Copy the following key term, definition, and example exactly as it appears into your notebook. The mean absolute deviation is an average of how much data values differ from the mean. Write the example, and also write these steps for finding the mean absolute deviation. Today we'll be starting on page 420 in your math textbook. Example 1, finding the mean absolute deviation. You record the numbers of raisins in 8 scoops of cereal. Find and interpret the mean absolute deviation of the data. So you have your list of numbers, and that would be 1, 2, 2, 2, 4, 4, 4, and 5. So step 1, you find the mean, just like you've always done. You add up your values, which comes to 24, and you divide by the number of values that you have, which is 8. So 24 divided by 8 is 3. And then step 2 is you can use a dot plot to organize the data. So it says replace each dot with its distance from the mean. So first of all, you make the dot plot like you normally would, and then you make another plot, and instead of dots, you use numbers. So 4 is 1 away from the mean, which remember the mean was 3. So instead of dots for 4, you put 1, 1, 1. 2 is 1 away from the mean. So instead of dots for the 2's, you put 1, 1, 1. So that's what we're looking at there. 5 is 2 away from the mean. So instead of a dot, you put a 2. And 3 is 2 away from the mean. So instead of a dot, you put a 2. Step 3, the sum of the distances. So you're adding up all these numbers in your new distance plot equals 10. And then step 4, the mean absolute deviation is that sum divided by the number of numbers you had. So that's 8. So 10 divided by 8 equals 1.25. So the data values differ from the mean by an average of 1.25 raisins. So moving on to example 2, our real-life application is on page 421. The smartphones show the number of runs allowed by 2 pitchers in their last 10 starts. And I know they're kind of hard to see on the phones, so I'm going to label these with the players' names. This is Mendoza. And this one is Rodriguez. And they're written out for you. They're typed out on the page, so it makes it a little bit easier to see. So letter A says find the mean, median, and mean absolute deviation of the numbers of runs allowed for each pitcher. So the first step is order the runs allowed for Mendoza. So they've done that for you. So they just put those in order. And so the mean is 3.5, and the median is 4 plus 4 divided by 2, which is 4. So when you cross out all the numbers on the left and the right, you end up with 2 4s in the middle. So it's 4. So now we're going to work on finding the mean absolute deviation. So you replace all of these dots in your dot plot with how far away they are from the mean. So 3.5 is your mean, and so you replace all of these dots with the distance away from 3.5. So 4 minus 3.5 is 0.5, so we replace that. And 3.5 minus 2 is 1.5, so we replace that dot with a 1.5. And 3.5 minus 0 is 3.5, so we replaced all 3 of those dots. So you have to replace each dot. And 5 minus 3.5 is 1.5. And 6 minus 3.5 is 2.5, so you replace those 2 dots. And 8 minus 3.5 is 4.5. So that gives you how far off each piece of data is from the mean. And so then you add up all of the numbers on your new plot, and you have 24, and you divide it by 10 because that's how many numbers there are, and you get 2.4. And then you repeat the same process with Rodriguez. You put the numbers in order so you can get your median, which is also 4, and you figure out your mode, so you add them all up and you divide by 10, and it's also 3.5. You do your dot plot, you replace the dots with their distance away from the mean, and you then add up all of these numbers. So the sum of these gives you the top of your fraction down here, which is 14, and then 14 divided by the number of numbers there are equals 1.4. So 14 divided by 10 is 1.4. And then in letter B, it says, which measure can you use to distinguish the data? What can you conclude about the pictures from this measure? So this is kind of important here. It says you cannot use the measures of center to distinguish the data because they are the same for each data set. So if you just look at the mean and the median, it doesn't tell you which picture is maybe better than the other because they both have the same mean and the same median. The measure of variation, MAD, which is the mean absolute deviation, is 2.4 for Mendoza and 1.4 for Rodriguez. This indicates that the data for Rodriguez has less variation. So you can see that up here, where we're looking at Mendoza's data, they might have the same central values, the same middle values, but Mendoza had a game where he had 8 runs allowed, and the highest runs allowed for Rodriguez was only 6. So Mendoza has more variation from the mean than Rodriguez does. So we want, in pitching anyway, we want to have a pitcher that doesn't have very much variation at all. We want to be able to count on our pitcher. Your assignment for this lesson is to complete the On Your Own problems 1 and 2 below. They are also on pages 420 and 421 of your textbook. Show your work and be prepared to share during our next class. There were a lot of steps in this lesson, so you're going to need to go back to the textbook or to the flipped lesson to look and see how to do these. Don't expect that you remembered it the first time around. So be sure you show your work, be sure you're ready to go. Please remember, to earn credit for viewing this flipped lesson, you must complete your exit slip, come to our next class prepared with the journal pages or other work from the flipped lesson completed, and be prepared with any work that was assigned in the flipped lesson completed. Be prepared with any questions you have for the teacher, and always have a good attitude. We'll see you next time in class.